We are talking about using GEMDAS to solve inequalities, and we want to solve inequalities by inverse operations, and we want to solve inequalities involving more than one step. So our directions here say, solve the following inequalities, write your answer in a set builder notation, interval notation, and graph your answer. So this is a one-step equation here. We only have addition. So, and then we have a positive 29 because we always take the number or the sign out in front of a number of a constant. If that number's not there, we understand that it is positive. So in order to get rid of a positive constant, we have to subtract 29 from both sides of the inequality. And we want to keep the inequality sign going the same direction. So that's going to be less than or equal to. The 29 and the 29 cancel, so then we're left with just x. And then we have to subtract 29 from 68. So we have to borrow from the 6, so that becomes 18. So 9, and 5 minus 2 is 39. So this says x is less than or equal to 39. What operation did we do here? So we did inverse operation, and that was subtraction. So now we have to graph our inequality. As long as the variable is on the left side, our inequality symbol will point the same direction as our graph on our number line. So the number that we need is 39. So I'm going to say 39 is right here. And we know that this is an equal to, so we should have a closed dot. So 39 is included. And our arrow says shade to the left. So I'm going to draw the line going to the left, and that will be a graphical representation of our answer here. Now in set builder notation, we already have the answer written in set builder notation. So I'm just going to rewrite that. X is less than or equal to 39. Now we come to interval notation. In interval notation, we need two edges to bracket it in, or two borders. So here we have 39. There's no number over top, so 39 was going to work. And now we need to find the bottom end of this. And this arrow here actually means that we are going to negative infinity. So for our interval notation, we need two values. We need the lowest value. In this case, the lowest value is negative infinity. And then we need the highest value. So in this case, it's 39. And now we have to decide how to finish this. If the number is included, we use a bracket. So here we have the equal to sign. We have the closed dot. That means that we use a bracket. This parenthesis, or this arrow here, means that we're going to use parenthesis, and we'll always use parenthesis whenever we're talking about infinity, either negative or positive, because we can never actually count to infinity. You'll never get there, so that can't be included, so we're going to use the parenthesis for that. If we take a look at the next one, we have x minus 4 is less than 7. So in this case, we're going to add 4 to both sides. And we'll still bring down our inequality sign, which is going to be less. So our 4 cancels, and we're left with x is less than, and in this case will be 11. How did we get x by itself over here? We used inverse addition. And now we want to be able to graph it. And so the number that we care about in this case is 11. So I'm going to pick 11 goes right here. And it says less than. So as long as the variable is on the left side, our arrow will point the same direction as our inequality sign. So we know that our arrow is going to go this way to the left. And we have to decide what kind of point we're going to use. Here we used a closed dot. because we had the equal to sign underneath. We are missing the equal to sign underneath here, so we're going to use an open dot. So say 11's not included, but 10.9999999 is included. So that's what that dot represents. And then set builder notation, we already have it written. So that can be x is less than 11. That's the set builder notation. And for interval notation, we need two values again. We need the high end, which we have. There's no representation higher than 11. So 11 is the highest. And then we need the lowest. So this arrow here means that we are going to negative infinity. That's what that arrow right there means. And so when we write it, we always write the smallest number on the left first. So that's going to be negative infinity. And then the highest value is 11. And then we have to decide how the end behavior acts. Is it included or not included? So here, infinity is never included. And then we have to look open circle. So there's no equal sign. So if it's open circle, we're going to close that with a parenthesis. And we can move on to example 3. And here we have another one-step equation, and I'm going to add 5 to both sides. And then we get 9 is less than or equal to x. So how did we get that? We did inverse addition. And when we go to graph that, we can just, 9 is the point that we're really concerned with. But the issue is we're kind of have this backwards. It's always easiest to have the variable on the left. So that's what I want to do. I want to switch this around. So I want to write the variable first, and then I have to get the sign correct because I'm switching where the number and the variable are. I have to switch the direction of the sign. So the large side is opening towards the x. So I want to make sure the large side still opens towards the x. So now we have x is greater than or equal to 9 going in the same direction. So 9 is the part that I care about. The equal to sign means that it's a closed dot. And because the variable's on the left, it's going to point in the direction I need to go. So I'm going to go to the right. All numbers bigger than 9. So my set builder notation is done already. X is greater than or equal to 9. In my interval notation, remember, we got to have two sides. We got to have the low side and the high side. So there's nothing over here. So the smallest is 9. And then this arrow means it's going to the right, means it's going to positive infinity. So those are going to be my two ends for this set. So we're going to have 9 and positive infinity. And then we have to decide if it's a parentheses or a bracket. In this case, we have an equal to sign going to the 9. So that needs to be a bracket. And the infinity is never included, so we use parentheses. Example 4, we look at the number out front, or the sign out front of the number. In this case, it's a 16 with nothing written out front, so we understand that it is positive. So then we can subtract 16 to get rid of both sides. And the reason we did that is inverse subtraction. And so we get x is less than or equal to, and then we have to take 54 minus 16. So we have to borrow 1 from the 5 there. So 14 minus 6 is 8. And 4 minus 1 is 3. So we have x is less than or equal to 38. The variable is on the left side, so we're all set there. So the point that I'm concerned with right now is 38. Then I have to decide if it's an open or closed circle. And this is going to be a closed circle because it has the equal sign, so closed dot. And now which way do I shade? The variable's on the left, so I go the same direction as the arrow. So then I shade to the left. Set builder notation is written already, so that's x is less than or equal to 38. And the interval notation, I have to make sure that I have two edges to the set that I have. 38 is the high side. There's nothing else above 38 drawn. And then what does that arrow mean? That arrow means we're going to negative infinity. So when I go to write my interval notation, I start at the lowest side, which in this case is negative infinity. And then I go to the highest value, which is 38. The equal sign here means that the 38 is included. And the arrow going to the left, going to negative infinity, we never include negative infinity, so that's going to be a parenthesis.